Hello, and welcome to today's live session, Pressure Sewer Systems, Enabling Creative Development Options for Thriving Neighborhoods. I'm Rachel Seiler, today's host and Marketing Communications Manager for E1. Before we get started, some housekeeping notes. All attendee lines have been muted. We'll be recording today's session, and an archived edition will be available on E1's website, as well as our YouTube channel. Upon successful completion of today's webinar, you'll receive a PDF of this presentation, as well as a certificate of attendance. And finally, we'd love to hear from you. We've allotted at least 15 minutes of Q&A during today's session, so please make use of this time. And if we don't get to all your questions, we'll answer them in a follow-up email. So now, without further delay, I'd like to introduce today's presenter, Chris Nedwick, Eastern Regional Sales Manager for E1. Chris has more than 10 years of experience in both wastewater sales and field service, and has guided many municipalities and builder developers through successful pressure sewer projects. Chris, take it away.
Hey, Rachel, can you hear me okay?
Absolutely, go right ahead.
Thank you very much for that introduction. And thank you, good afternoon, one and all. Thank you for taking time to join today's webinar. Today, hopefully, you're going to learn more about E1 all-terrain sewers, specifically how we can help builders and land developers locate land, manage cash flows, and increase profits by lowering upfront costs for sewage infrastructure. So, unlike gravity, E1 ATS is a smart, appropriate sewer technology consisting of small diameter, low pressure sewer pipe networks, which only require a minimal excavation to install, are extremely flexible, and they follow the natural contour of the land. That's a phrase you're going to hear periodically throughout this presentation today. Frequently, our systems are installed with a backhoe, a small excavator, a trenching machine, or through directional boring, closed trenching techniques, which we're seeing much more of these days. This means that you or your customers can install a smart sewer system without extensive excavation, and that you no longer have to deal with grade, raise, and fill requirements in order to get a gravity system to pitch and work the way it's supposed to within the restrictions of a given application. Far more so than gravity sewer, E1 ATS, again, ATS is all-terrain sewer, can actually help the land acquisition professional find usable land. And this is something that we talk about all the time. This is because ATS is a highly adaptable, efficient method of collection that can pump up and down, around, throughout a wide range of topographical and geological conditions. And because it greatly reduces or completely eliminates the need for costly lift stations. Many municipal regulators are requiring that builder developers install very costly lift stations in accordance with their specifications, not your specifications or your customer specifications. And all too frequently, frankly, this is held over the head of the developer, and they must simply comply with what's being specified or forced on them, really, or risk potentially significant delays in project timelines. You can't simply tell the local town or sewer district, no, I won't build the lift station that you want me to build. I'll build the one that I want. It doesn't work that way. And we know from speaking with customers that these lift stations, they can cost several $100,000 each, or sometimes millions of dollars each. And who wouldn't prefer using that valuable land for more product as opposed to lift stations? So in this presentation, we've included several examples of the kind of CapEx reduction that E1 can help you achieve. Many documented cases indicate these savings can be as high as 50% or greater. Again, this is made possible by the fact that we reduce or eliminate costly lift stations because our system doesn't require large, deep pipes and associated excavation and equipment costs. You're going to learn more about how E1 ATS helps a developer manage cash flows by spreading out and deferring sewer costs, over time. With gravity sewers, the land developer must install all of the pipe up front. These can be large, costly pipes that require critical slope, large open trenching, and lift stations, once again, with costly SCADA systems, backup generators, and other expensive commercial design functions and features. Often the residential home builder must sub out this lift station work to a qualified commercial group for completion, which comes with a whole host of different regulations, inspections, and ongoing costs. A lot of times the builder developer is responsible for maintaining that lift station almost in perpetuity. More often than not, this means the builder must shell out hundreds of thousands again, or sometimes millions of dollars up front, and hope that they get the expected return on investment within a few years. And that's assuming that the market stays hot so that they can pay off that development loan. So how does E1 help manage cash flows? This is a question that we get quite a bit. Well, conversely, with ATS, the builder can install a small diameter, flexible HDPE, or high density polyethylene sewer force main, at a fraction of the price as gravity. So after saving 50% or more on related upfront force main costs, they can then add grinder pump stations as they receive purchase orders for new homes as they go, and as the project evolves. This is the power of E1 ATS, which has the potential to transform projects really from potential liabilities in some cases to provide profitable communities with limited risk that can be brought to the market efficiently while minimizing financial stress on the organization. And just advancing the slide. Please bear with me while I advance the slide. Okay, we advanced the slide. Sorry about that. So I wanted to really start by talking about who we are. We have been in Niskayuna, New York since 1969, the same place from day one. Our facility is 75,000 plus square feet. We've got approximately 120 employees, and our main business is our sewer systems business. And please bear with me while we advance the slide. There we go. So this is not a alternative technology. This is an appropriate sewer technology. Again, 5+ decades in use. This slide demonstrates the breadth and the scope of our installation base. Here domestically in the United States, we've got mainstream municipal installations. If you take a look at Indianapolis, Indiana, 9,000 plus units, Fairfield, Glade, Tennessee, 3,000 plus units, Grand Strand, which is the Myrtle Beach area in South Carolina, 3,000 plus units. The list goes on and on and on. Globally, in Scandinavia, we've got 100,000 plus units. In Australia, 20,000 units. We're in the midst of a project on Mornington Peninsula that will see 16,000 homes connected to an E1 system once it's complete. The amount of sizable installations that we have is really, really impressive. And again, some of it go back to the early 1970s since our beginning. We started as a General Electric spin-off, and this technology, we don't consider ourselves a pump manufacturer per se, although we make the best purpose-built pump for the application. We consider ourselves a solution provider and system provider. But we were a spinoff of GE back in the 1960s. And from day one, the concept was to make this an appliance that did not require any preventative maintenance whatsoever and would deliver decades of reliable service to the end user. And that's really been the driving philosophy from day one. We'll talk more about that in the presentation here. But we are a global market leader in the sewer systems, low pressure sewer systems space. Again, we created this market back in the late 1960s. We're in 46 countries now. We have this singular focus on the system or the solution. And we'll talk more about the value adds that we deliver to builder developers and engineers throughout the globe more in the presentation. But in a nutshell, we've got 800,000 of these systems out there, and approximately 2 million users are served daily by an E1 sewer system. I also like to point out that every day we connect about 180 homes to an E1 sewer system someplace, somewhere throughout the globe. So again, as a solution provider, our mission is to provide complete and accurate design recommendations for sewer systems, really from the inception or concept phase all the way up to implementation throughout the life of the system. We establish relationships for life with our customers as the trusted advisor. We are going to make recommendations from a design standpoint, from a best practices standpoint, from a service and ongoing support standpoint. And, that's something that we do every day. We take a great deal of pride in that. So the concept of helping land development professionals find land, again, comes up pretty frequently in our conversations out in the marketplace. What we mean by that is E1 ATS by nature, because it's a small diameter pipe network that's not large and kind of clunky like gravity can be, as I mentioned kind of in my opening statement there, it's going to open up a lot of opportunities for the potential project that you may be aware of, or maybe it's a piece of land that you passed on 5 or 6 years ago. You might want to take another look at it because the customer may have commissioned an engineer or conducted their own engineering study and realized that the cost of sewering that parcel would have been prohibitive or made it so that the project would not have been profitable. Well, because we can save 50+% often from a capital expenditure standpoint compared to gravity, developers can then go look at that piece of property again and potentially turn it into a profitable project. So we open up the availability of potential land significantly by reducing sewer costs. Also, the concept of cash flow management, as I mentioned in my opening statement, really is very appealing to a lot of builder developers because, again, rather than installing all that costly gravity infrastructure up front, you're installing a small diameter force main at a fraction of the price of gravity, and then you're adding grinder pump systems as you go and deferring those costs as you get purchase orders for product actually to the consumer. So that is really as appealing as CapEx reduction to many of the builders that I've talked to throughout the years. And this provides a competitive advantage, frankly, because if you're aware of this technology and your competition isn't, well, then you now have a competitive advantage over them in your marketplace. And from a labor and material cost standpoint, there's far less material involved with low pressure sewer systems. You don't have manholes. Again, as I mentioned, you don't have big costly lift stations. You don't have large diameter pipes and joints. You don't have all the ongoing maintenance associated with keeping that system functioning. But one of the points I always make is that, nowadays in 2020, labor is really one of the most expensive line items on any balance sheet. Typically, one of the top 3 expenses for any organization is labor. So we're going to make that labor cost go down because of the fact that this is a minimally invasive technology that can be installed very easily. And last but not least, you're increasing profit margins, obviously. Anytime that you are reducing costs while delivering the same product at the same price point, your profit margin is going to increase. So the way that we approach this business, again, I'm going to keep hitting the same point. We are a solution provider and a system provider. We really want to be involved in these projects with the engineer of record, really from concept phase through implementation. And the reason we want to do that is because as a purpose-built technology, we really go the extra mile to ensure that the system's going to design as advertised the way that we want it to, that it's going to deliver years and decades of reliable, low-cost value to your consumers. Our equipment, our pump systems, our panels, everything's interchangeable. We streamline that aspect of things. For the folks that work on hydraulics, this is going to be familiar to you, but we really put a lot of emphasis on the design of our pump. We want to ensure that the products that we're putting out into the marketplace are providing consistent and predictable flow because as we all know, pressure sewer systems are subject to varying system pressures. So you want to have a pump that's going to work pretty much no matter where you put it. That distinguishes us virtually from everyone else in the marketplace. We've got a pump that's designed specifically for this application. You set it and forget it. Your phone is not going to be ringing when people are having issues related to hydraulics if you're using E1 ATS. The actual grinder itself, it does not jam. So again, as an appliance, there's no preventative maintenance necessary. So we've got a low inlet velocity grinding mechanism to prevent clogging. And we've also put a lot of emphasis on simplicity of repair and or replacement because this has a direct impact on ongoing costs. So when to use pressure sewer systems? The answer to that question is really whenever the flows are appropriate. This technology is going to give you a competitive edge relative to gravity, almost 100% of the time, again, as long as the flows are appropriate. But wherever you've got flat terrain, what goes down must be pumped back up. So with gravity, where you've got flat terrain, you might see, a higher incidence of lift stations in some of those situations. Deep sewer, is very costly sewer. So where you've got a flat terrain, you certainly have that dynamic at play. Where there's a high water table, where the terrain is wet, this is another type of condition that is very well suited to using low pressure. Where you've got a lot of high rock content, where the terrain is hilly, where you've, again, got high water table. And also, if you've got some existing gravity, this might be interesting to some of the builders joining us today. If you've got an existing installation, let's say it's a community and you've got some open lots in that community, but you've got a gravity system already installed, well, guess what? We can help you turn those low-lying lots into more product, because the E1 ProCav pump is going to be able to reliably and dependably discharge to an existing gravity sewer with no issues whatsoever. It's a very seamless interconnection. So more advantages to the builder. Again, it's small diameter, right? And it follows the contour of the land, so you're reducing your installation costs significantly. I'll say it again, those big costly lift stations that no one likes, that are kind of forced on us, those go away or can be greatly reduced. And there's some examples of case studies in this presentation where we point some of that out. We mentioned deferring costs to the purchaser, and CapEx reduction of 50% is very common. And I'll just say that we've seen cases where it's far greater than 50% depending on the application. Also, having a light touch on the landscape preserves natural site beauty. A lot of communities now place a great deal of emphasis on, kind of blending into the natural environment. So with pressure sewer, you don't have extensive excavation taking place. You're not literally tearing up the land to get the sewer system to work. You're injecting a small pipe in some cases into the landscape and blending in seamlessly with the landscape. So this allows the designer to maximize the aesthetic qualities of a given community by having that minimally invasive characteristic. If increased lot density is important to you or your customers, we certainly can help with that. Smaller diameter pipes mean, you can have a higher building density on that particular parcel. And also difficult sites, as I mentioned earlier, can be transformed into profitable projects. Maybe there's a parcel that's on the waterfront, the soil won't percolate, and, you really can't do much with it. Well, if you utilize E1 ATS, and you've got a sewer system to pump to, we can help you turn that into money. So about 6 years ago now, maybe more, 7 years ago, we came up with the concept of ATS. And it's really just a way to call attention to the fact that this truly is an all-terrain mainstream sewer technology that can really open up a world of options and flexibility for the land developer. It can help you sewer literally any parcel that you could possibly imagine. I would just take this time to encourage everyone on the call to go out to e1.com or our YouTube channel, Environment One Sewer Systems on YouTube, and look at some of the case studies we have. We've got a wide array and a vast collection of builder developer case studies where principals are testifying to the fact that this technology and the support of our company and the focus of our company and guidance as a trusted advisor had allowed them in many cases to sewer the most challenging and difficult areas and really turn them into very successful communities and projects for their businesses. We go 5 years on our warranty. It's the only comprehensive warranty in the industry. It literally covers everything you could possibly imagine. So what does that mean for you and your clients? It means that, if you sell a house with an E1 sewer system and there's some type of issue, 4 years from now, 5 years from now, it's not going to cost your consumer anything typically for us to go out there and deal with that issue, as long as it is a warranty issue. We provide 24/7 service support, 24/7 job site support. So what that means for your customers is if you're short on something and you need anything you can possibly think of related to that pressure sewer application. Our distribution network is going to be there on site to support your people and make sure that they have what they need to meet their deadlines. And regular representative contact is critical with us. We want to know who our customers are face to face so that we can provide that industry leading customer service. So this slide demonstrates what the system looks like. It's kind of the ant farm view, if you will, of what this system looks like when it's installed in the ground, if you were looking at it from the side. So we'll just start on the right side of the frame here. You'll see the house with the E1 Sentry alarm panel. You know, builder developers and engineers tend to be very aesthetic, very focused on aesthetics. You know, you're delivering industry leading products to the marketplace. The last thing in the world you want is a large, clunky, ugly looking control panel somewhere on the side of $1 million home. So we go through a lot of effort to make sure that our products are blending in with you know, the environment and are as pleasing to look at as possible. So that's that alarm panel. It's gray, the same color of the foundation. Typically it's that way for a reason. It's a NEMA 4X panel, which means it's largely going to be waterproof under normal conditions. Connecting the grinder pump station, which is in the center of the frame, is usually a piece of 3/4 inch or 1 inch conduit buried underground, and that connects the electrical service to that station. And down below that, you'll see what's typically a 4-inch DWV PVC inlet, which is transferring via gravity the household waste to the grinder pump station. And what happens in the wet well portion of this tank is that wastewater will fill up and fill up and fill up until it activates an on-off switch. Our pumps use pressure switches. We don't use floats. And without getting too far into the weeds here, anybody that has, we all have washing machines and dishwashers in our homes. They use pressure switches to sense water column or water level. At least once upon a time, most of them did. A lot of them are digital now, but it's an incredibly reliable, simple appliance-based control system. And what that means for this application is that nobody needs to go out there and open a cover and try to figure out why a pump's not working, because people put a lot of things down the drain that can interfere with pump operation. And I don't care if it's a single grinder pump station or $1 million lift station. Eventually, if there's a lot of stuff that doesn't belong down the drain going into the wastewater system, it could cause an issue. Well, with our system, that doesn't happen typically because we use pressure switches, which don't come in contact with wastewater, and we use a grinding mechanism that does not jam. So we don't want your phone to ring, 5, 6, 10 years from now with somebody that's unhappy because somebody's had to go out and clean off floats in their grinder pump station. We stay away from that. We've had this pressure switch design, which is fully automatic, no preventative maintenance required from day one, dating all the way back to 1969. Exiting the station itself, well, before we do that, I want to just call attention to the fact that this is the top of the station. This will be grade, and this is literally all the customer is going to see. It's a green cover, which is a nice earth tone green, and it blends in very well with the surrounding environment. We've got some pictures of it further in the presentation here. Anyway, this is the discharge on the left side. It's a small diameter 1.25 inch discharge. It connects to really the gateway to the system, which is that stainless steel unilateral. Being a unilateral, it has really 3 features in one. It is a fully ported ball valve / isolation valve so that you can isolate this discharge line from system pressure if you needed to. It also has a clean out, and it also has a fully ported flapper style check valve, which prevents backflow of any kind. So if you're wondering about backflow, it's not an issue for any one system because we've got that backflow protection up here at the curb, and we've got it also built into it's intrinsically featured in the pump itself. So we've got double backflow prevention to protect customers. And this is the demarcation point typically between private and public. And then you've got your small diameter, low pressure sewer force main out there in the street that again can be installed at a fraction of the price of gravity. I want to just spend, a minute here talking about the most common product that we see probably anywhere, which is our D-series station. In a nutshell, this is a station that it's consistent with the design philosophy from day one, where safety and serviceability and reliability are the main motivators or the main influencers in the design itself. So that top that you see in the tank there, there's no wastewater there. That is always a dry environment. So that adds a layer of safety and also makes it easier to service typically. All the discharge components inside of that station are stainless steel. So they're going to last for decades and decades and are not subject to corrosion. These are variable up to 160 inches for this model. Really would get you up to about 200 inches with other models. So what that means is that adds some flexibility for where you can locate these stations. If you want to get it up closer to the road, then typically you would need a deeper station for that. But we can accommodate pretty much anything that you can envision for this application. Serviceability, why is it important to the builder developer? Why is it important to the engineer? Because we always want to specify and install products that are going to minimize service liabilities. That really, once again, is front and center in everything that we do. We want the experience of the service individual to be safe, to be efficient. So we're constantly thinking about this. We use what we call a core concept. Again, it's fully interchangeable, but little things like this electrical quick disconnect will replace a junction box. So what that means is it's easier for the technician to deal with that if they ever need to in the future. And again, everything on this pump is designed for ease of service and reliability as well as safety. Again, without getting too far into the weeds here, but we're very happy to talk about technical matters related to the design of this pump and the application. We hope to get some of your questions at the end about the design of the progressing cavity pump and some of the different components that go into it. But what this slide shows is kind of the insides of the pump itself. We'll start at the bottom. That's a large diameter, 5 1/4 inch grinder, right? So it's a grinder. It's not a cutter. Doesn't need to be sharp to work. It spins kind of slower with a lot of torque. And what that means is it doesn't jam. That is above it. The black item that you see is the stator. That's really the pumping mechanism itself. We've got an air-filled motor. Again, this is an appliance, folks. We're different than most pump manufacturers. We're looking at this as an appliance. We want it to be fully automatic and not require any maintenance, preventative maintenance whatsoever. So we use an air-filled motor. We have from day one. We have the controls located directly on top of the motor itself. And again, those are the pressure switches at the top, which never come in contact with wastewater. They're actuated by air column, air pressure, if you will. So in keeping with this concept of service and kind of, downstream, benefits of keeping service front and center and everything that we do from a design standpoint, we offer remote monitoring capabilities with this product. It's called the Sentry Advisor. It's becoming one of the most common types of panels that we see out there. But basically, it's a cellular-based alarm system. What this means for your clients and your end users is basically if there's some kind of service issue. And by the way, I'd like to point out third-party data from, again, the course of 50 plus years of doing this indicates that the mean time between service calls on an E1 asset is between 8 and 10 years. So that means once every decade, sometimes more, you'll have some type of service alarm. That doesn't mean the pump will be broken. It may not even mean that anything needs to be changed or fixed. It just means that factored out over the arc of history, third-party data indicates once every decade or so, there'll be an alarm of some type. So it's incredibly infrequent. But if there is an issue, we offer remote Sentry Advisor alarm capabilities, which is going to notify the service entity of an issue that needs to be investigated, typically before the homeowner even knows there's a problem. So we're trying to make that service asset to service capability as seamless and efficient as possible. We want these assets to be invisible to the homeowner. As much as we appreciate and love wastewater, it's what we do every day. It's our passion. When my phone rings and it's a homeowner and they say they've owned the house for 25 years and they had no idea that they even had this pump system, I take satisfaction in that. I'm never happy that someone's had a service issue, but when the asset is invisible to the homeowner is when we know we're doing our job. So I want to talk briefly about some case studies, some examples where builder developers have used E1 all-terrain sewer technology with success. This is a small developer up in upstate New York in the Adirondack Mountains, which is it is the largest state park system anywhere in the United States, as far as I know. But a lot of ecological, environmental restrictions on development. This is a developer who wanted to build a community with high-end homes. This is $1 million plus, I think, is the entry price point on this community. But it was very important to them. Number one, they needed a sewer system that was going to work. It's very hilly, it's mountainous, very high rock content. There's a lot of granite, a lot of shale. They wanted a non-invasive system to preserve the aesthetic of the community. People were buying weekend homes up there because they appreciated the aesthetics and the outdoor benefits and qualities of this particular region. So they didn't want to have a gravity system, which essentially would have meant they would have had to dig the place up to get the gravity system to work. And they realized through an engineering study that the gravity sewers would have required, multiple lift stations. And again, those can be very costly. So this is an example of one of the homes. E1 grinder pump stations were installed as homes were built. I mentioned this earlier. This is the cash deferment aspect of our technology. So they installed the force main where they needed to out in the street. Again, small diameter, very easy to install. And as they're building homes, as they're getting purchase orders for homes, they're adding their sewer system as they go. That was very important to this developer. Large treed private lots had a kind of a neighborhood feel. The all-terrain sewer system allowed engineers, again, to maximize vistas and aesthetics related to each parcel. The estimated cost for gravity in this community would have been about $800,000 or roughly $30,000 per lot. Conversely, the E1 ATS system cost per lot was approximately $10,000. So we saved this developer $20,000 per lot right off the bat by going with ATS as opposed to gravity. The next case study is up in Nova Scotia, Canada, a very beautiful community, which is being built as we speak. It's called Seven Lakes. Now, Seven Lakes is, again, much like Whiteface Club and Resort. It's kind of a weekend community. It's not a retirement community, but a lot of baby boomers are moving up there to get out and enjoy the outdoors and do more outdoor activities. It's built around a series of lakes. But again, like most of your clients, most of the folks on the call today, they really were very conscious of the surrounding environment and wanted to maximize the aesthetics of the community itself. So they didn't, like the previous example, they didn't want a sewer system that would be very disruptive, aka gravity. So they started looking at the E1 all-terrain sewer option. And some of the complications here, soil and bedrock conditions really were not conducive to gravity. It would have cost millions to install. The gravity sewer installation is high impact, and in their opinion, it posed a threat to the existing environment in some ways. And they didn't want to put in septic tanks because they knew eventually they would fail and cause ecological issues for water quality. So they really started to zero in on E1 ATS, and with our support, they were able to install an all-terrain sewer system. The pressure force mains range in size from 2 inches to 4 inches. The estimated gravity cost per connection was about $30,000. Again, very similar to Whiteface Club and Resort. The low pressure sewer cost per home was about $5,000. We saved them roughly $25,000 per lot. An incredible cost savings. And again, just like Whiteface Club and Resort, they were able to defer those costs, and the sewer system itself was not a significant financial strain on the organization, and they didn't have all that money tied up in expensive gravity sewer that would have taken years to return on their investment. And another example here is Great Sky down in Georgia, very sizable at 2,800 connections. This is a full amenity development, including tennis courts, pools, clubhouses, various outdoor activities. But like the previous two examples, there's a lot of mountainous views. It's, if you can imagine, the gorgeous green hills of Georgia. It's hilly and it's wet. Like a lot of places in Georgia, there's a very high clay content to the soil. It's built around a very environmentally sensitive lake. The gravity option would have equated to 17 lift stations. You can imagine the cost that would have been associated with that. The developer investigated numerous solutions, but all roads kept leading back to E1 all-terrain sewer. And pressure sewers, they realized, limited disruption to the natural environment, eliminated the gravity lift stations, which equated to an $8.5 million net savings, or roughly $3,500 per lot. So once again, significant cost savings associated with ATS. And it created, by the way, to get back to the density issue, or really the lift station elimination benefit of opening up more land for product, it created more available building sites by using land allocated for lift stations. So they were able to put more houses in there, which is the name of the game. I wanted to highlight a couple of Toll Brothers projects that we've been involved with for the last couple of years. E1 is the exclusive low pressure sewer provider for Toll Brothers, and we've partnered with them on several very successful installations. I wanted to start with Shelton Cove in Connecticut because it demonstrates the adaptability of the technology. Like the other examples, this is close to the water. Water is an integral aspect of this community's character. This is the Housatonic River, very historic area. But basically, these are row houses. So this is clustered housing that's connected to single E1 duplex stations. So it's not always just one station, one simplex. You can accommodate cluster town or row house type communities with E1 and still achieve those benefits that we've discussed related to CapEx and deferring costs. This particular project was a HOBI award winner for best townhome community, and it's really been highlighted pretty extensively by Toll Brothers. This is Steeplechase in Branchburg Township in New Jersey. The first time I pulled into this community, I was just awestruck. Just a gorgeous community. The product is just like nothing you've seen. These are very large houses, some of which are 6,000 and 7,000 square feet. But anyway, E1 helped with Toll Brothers on this project by providing design recommendations up front. We're able to demonstrate that by using E1 ATS, not only could they maximize the surrounding beauty of the environment with this project, but they could also fit some more houses in and really maximize the profits for this project itself. It's sewered with duplex stations because of the size of the homes. But again, from talking to the project manager on this project, they were able to really, from a speed to market standpoint, they were able to get a lot of these houses up very quickly by using E1 ATS due to the fact that it's minimally invasive and it's so easy to install that force main. They weren't spending a lot of time, really weeks and months, with massive excavation efforts that would have been associated with gravity. So very successful E1 Toll Brothers project. We talked a little bit about what it looks like installed, but again, it's a product that's going to be largely invisible to the homeowner, and we do put a lot of emphasis on making sure that it's installed properly, which leads me to our certified installation program. Now, as the trusted advisor, it's very important to us that these assets work as intended and deliver decades of reliable, low-cost service to the end user. We don't want people swapping our pumps out, 10 or 15 years down the road. We want those pumps to last for a very long time. One of the ways that we help ensure that is we provide free certified installation services. And basically what we have is an app that we've developed that walks the contractor through the installation process. There's a series of what I call photographic checkpoints where you're actually via your smartphone, you're documenting, photographically documenting, what is the installation like, what type of backfill material used, what does the hole look like, what's the height of the station, is it installed properly in that respect. And we know that properly installed E1 stations really stand out and deliver pretty amazing service life and value to the end user. So we put a lot of emphasis in this technology, and also from a personnel standpoint. What it means is we're going to come to your job site. We're gonna train your contractors. We're gonna train the folks that install these things. We're gonna train your people. We're gonna certify them, give them a certificate that proves that they attended this training, and we're doing this again to make sure that this asset is gonna operate reliably, and that's all done free of charge. And this shows a little bit of what it's like to install one of these stations. As you could tell, as I mentioned, just a small backhoe is all you need to install these grinder pumps, and the trenches are, minimal, relatively speaking. There's not a lot of excavation taking place here. And this slide shows what the customer sees. We've got rock options available. I happen to think that our access way cover is very pleasing to the eye. Some folks may not want to look at it, so maybe they'll install it behind a bush or someplace where it won't be noticed. But if it's important to them and they wanted to cover it up, we do have rock options that are available that are also very pleasing from an aesthetics standpoint. So for the engineers and really for everybody on the call today, and thank you all once again for your time. This is a appliance, again, as I've mentioned several times during this presentation. So it is UL certified as a complete assembly. Now, what does that mean to the engineer? What does that mean to the end user and the builder developer? Well, we all want the same things. We want appliances to work safely. We want safety to be front and center in everything we do. That's the most important thing to us as a company, is that our systems and our people operate safely. UL certification, CUL certifications as a complete assembly, what that means is that our products, and they're the only products in the industry that are UL certified as a complete assembly, have been subject to and passed really the most rigorous requirements from an appliance safety and reliability standpoint anywhere around the globe. So if you put your stamp of approval on an E1 system, just know it's got UL and CUL stamp of approval as well. This is not a product that just comes off the shelf from a warehouse someplace. This is a purpose-built system with very stringent, high-level appliance safety-related certifications. Field service, again, very important that we support our end users really 24/7, no matter what. What this means is that we have a global distribution network where service is really front and center in everything they do. With 800,000 plus systems out there, we've got a very good sense of what that apparatus should look like, what that level of support should look like. Basically, what it means is if there's any type of service issue, it doesn't matter if you bought your E1 asset 30 years ago, our people are going to show up. We're going to get there typically within 2 hours, and we're going to deal with that problem 24/7, rain or shine, to make sure that the sewer system is working the way that it's designed, and to make sure that end users are fully supported and satisfied. So just know, this is not a product that somebody's just going to plop in the ground and walk away from. We are there to support our customers 110% of the time, and many engineers and end users take a great deal of comfort and satisfaction and confidence really from that. So in summary, E1 is the worldwide leader in pressure sewers. It's a market that we invented back in the 1960s. We continue to lead in the pressure sewer space today. Again, fast forward to today, 800,000 plus systems out there, numerous examples of, installations with 5,000 or more connections all around the globe. We're sewering massive projects everywhere from Long Island to Australia, to Indiana, to the Florida Keys, and many places in between. It's an appropriate mainstream technology. For the land development professionals out there, I want you guys to understand that it's going to help you find land by opening up new opportunities, by reducing costs, and really from an application standpoint, opening up opportunities by allowing you to sewer difficult, if not impossible, applications, from a traditional gravity standpoint. Managing cash flow and deferring costs, we talked quite a bit about that. But again, this is something that's very important to the builder developers out there. Certainly in this environment, in any environment, we want to make sure that cash management piece is really being focused on, and we're going to help in that area significantly. Again, it's going to provide a competitive advantage. If you know about this better mousetrap and your competitor does not, well, you now have a competitive advantage over them in your market. We're going to help you reduce your labor costs and your material costs, which is going to increase profits substantially in many cases. And we're here 24/7 to talk to you guys and your end users and your customers about E1 ATS. If you've got a potential application that you're curious about, we've got life cycle cost calculators, various tools that we can use to compare what that upfront cost is going to look like, what that ongoing cost is going to look like. We do all that free of charge. We're happy to talk to you. We're happy to walk you through the process. And you may decide to go in a different direction, but we just appreciate that opportunity to at least educate and have an ongoing discussion about this very valuable and significant technology, again, that we have used for 5+ decades now throughout the globe. And with that, I'd like to thank everyone once again. And Rachel, I'll turn it back to you.
Okay, Chris, thanks. That was a great presentation. And as promised, we'll start right in on our Q&A session. So Chris, if you're ready, we have a question on the more technical side of things coming in from Greece, believe it or not. Why do you call it a low pressure system when the pump can reach 52 meters total head?
That's a great question. I think, frankly, I think that dates back to the inception of the technology. I think the term high pressure sewer maybe was a little bit scary to some people. You know, the pump is capable of producing significant appropriate pressure for the application. We don't let it get too crazy, but that's really what it was called from day one, and we just have stuck with it over the years. ATS, all-terrain sewer, is you know, now been introduced kind of into the lexicon, and you know, it's just a great question. I got to tell you, I've been doing this for a long time. That's the first time anyone's asked that question. I really appreciate it. Thank you.
All right. So this is coming from Raymond. He says he has a small country residential subdivision with about 15 lots at the final build out. And the discharge is 0.5 miles away. Would this be a problem with only a few houses on the line at startup?
What size is the pipe, did he say?
No, he didn't say the pipe. He said where the discharge is.
Gotcha.
It's
Yeah.
about a half a mile away.
Perfect. So no, not an issue whatsoever. On a flat plane, we can go 2.5 miles, if not more in some cases, with an E1, single E1 grinder pump. So no, Raymond, it's not an issue. We're just going to want to make sure that that pipe is sized appropriately, that the velocities are where we need them to be, and the total dynamic head is where we need it to be as well. So we're going to make sure hydraulically that it's designed appropriately, but that's not an issue whatsoever, and it really speaks to the versatility of the application.
Okay, thanks for that, Chris. This coming in from Keith, and he's just weighed in with a second question too. So we'll take his first one first. There is an obvious financial benefit to the developer. However, the builder is now having to install the E1 system. So adding the cost of the E1 unit and install, is there a total savings for the development?
Well, first of all, another great question. Thank you. First of all, E1 does not require assembly on site. So it's a plug and play product. That D series product that we see the most of, most utilization out in the marketplace, is going to come fully assembled. So it's fully assembled and tested before it arrives to the job site. So there's not a great deal of tinkering taking place on location. We know that when you add up all the labor cost, which is captured in what we call the installation cost, and you add it to the material cost, it's not uncommon to see $12,500, $13,000 per connection. You'd be hard pressed to install a gravity system for that amount. I'm not saying it's not possible, but it's certainly not common. You know, on the low end of things, the net savings with E1 ATS compared to gravity is typically going to be in the 25-30% range. But as we mentioned, we see savings of 50% or more pretty frequently. So when you factor in all costs and you factor in, you know, the plug and play design of the E1 station, which again is going to minimize that labor cost on site, we know when you totalize everything, there is still a very significant savings. I hope that answers the question.
Okay, and his second question is, what is the most common maintenance item?
Sure, it's going to be the stator, which is, I guess, a wear item, technically speaking. You know, under normal operation, it's going to go, you know, 10+ years, sometimes way more than that. But it's a stator. It's relatively low cost. I think for, you know, the cost for the part itself is less than $100 or right around there. But very low cost issue to deal with. And again, it's going to happen very infrequently.
Gotcha. Okay, this in from Michael. Is it feasible for a single residence?
Absolutely. I'd say most of our residents, well, if you're talking about a system just with one house and a grinder pump pumping to something, absolutely. Very feasible, very practical. A lot of times what we'll see is an E1 station pumping to a septic tank. Let's say, that's an acceptable arrangement. And somebody's got a waterfront parcel and they've got to get sewage from point A to point B. They'll pump to a septic field with an E1. You're going to want to work with an engineer to make sure that septic tank is designed appropriately, but absolutely feasible, absolutely cost effective, and very common.
Okay, we've had some more questions come in. What options would you suggest for private treatment systems when municipal or formal utility district treatment facilities are unavailable?
It's a tough thing to answer. It depends on what your flow rates are, how many connections you have, what part of the country you're in. We do see membrane on-site treatment used. We see other types of on-site treatment used as well. We don't officially endorse any on-site products out there, but I will tell you, in the northeastern United States, we see biomicrobics fast system used pretty frequently, but again, that really depends on what's going on the location. There's a number of different factors that go into those decisions. E1 has been used successfully with on-site systems for decades. You're going to want to talk to, our distributors more times than not, wherever you are in the country, are going to be able to walk you through that process and let you know, what's been used successfully locally.
Right, as well as, municipal regulations and so forth, I would think.
100%. Again, we don't endorse any company or anything, but we do see membrane style used, I think, with some degree of frequency up here.
Okay, thank you. How do you design for vacation homes around lakes? In the winter, owners are gone and the entire system flows are very low. In the summer, the flows are higher and very high on holidays.
Yeah, seasonal applications can be a challenge. However, with E1, if we're working with you on that design, again, from the inception, it doesn't need to be really much of a challenge at all. So I'll start with the design method, which is the probability method, which is incredibly forgiving and versatile, really, is the proper term. But what you're going to find with an E1 pressure sewer system is that it's very adaptable. So you're going to get a lot more homes on a smaller diameter pipe than you think. If it's in the higher range and the velocities are a little bit high, we're going to want to make sure that they're appropriate. But even if it's in the lower range, the system is still going to work. The most frequent issue that you'll see really isn't hydraulic. It's kind of hard to categorize, but it's odors, right? So you'll have septicity. So where you've got a pipe that might be designed for 20 homes and there's only 2 houses on it, you're obviously not going to have the velocities in that line like you would if there were more connections and more flow. So in those cases, we would recommend a flushing connection so that periodically you can go in and flush out a line if you need to. We're also going to help you work with your end users and make sure that before they go on vacation, they're introducing some fresh water to the system. This can be achieved simply by filling up a bathtub with water and then just releasing it. Oftentimes that's sufficient. But from a hydraulic standpoint, more times than not, there doesn't really present any serious issues. You're just going to want to keep an eye on things like odors and corrosion. But if you're building in those design aspects like a flushing connection and you're educating the populace that's using the system, the vast majority of cases, seasonal applications are not a problem for E1. We've been doing those for years with a very high degree of success. But I also want to just take this opportunity to say, please give us a call. Let us know what you got going on. We've got the best application engineers in the world who can speak to that challenge, far more comprehensively than I can. And they're going to walk you through it and make sure that you get the right design up front that will help deal with that situation.
And this kind of feeds into that. You kind of answered it, but we'll just ask this question anyway. For small developments with low flows, do you see mainline pipes of 1 1/4 to 1.5 inch diameter to maintain velocity?
It depends on the pipe type and also who's doing the design. Sometimes 1.5 inch has a small ID, and it does not have much capacity beyond 2 stations, frankly. So usually we just start with a 2-inch line and save the transition and allow for a larger size clean out at the end of the main. You can also meet flushing velocity in 2-inch SDR11 HDPE pipe with only a couple stations. SDR21 PVC has a much larger ID, and we'd usually start with that to meet flushing velocity. So we'd probably just get you up to a 2-inch if it's possible, rather than 1.5 inches or 1.25 inches. Inch and a quarter is going to be our standard discharge from the tank itself to the force main. But once up there, we'd probably rather get you into a 2-inch force main.
Okay, and I think this is going to be our last question, unless some more come in. But if you install a pressure system for an entire development and the actual development does not happen as quickly as thought, what happens?
Yeah, it goes back to it's similar to the previous two, I think 2 questions ago now. Seasonal, build out, these are all dealing with low flow scenarios. We're going to want to understand what the final scope of that project is going to look like. There's a couple different ways to solve that riddle. You can go with a size line that would be needed to adequately serve all of the expected connections, in which case you're going to want to utilize the flushing connections like we talked about. You're going to want to utilize some of the freshwater techniques, if you will, that we discussed as well. Some developers will put in a second line for road, so to speak. I mean, pressure sewer pipe is not costly from a material or installation standpoint. That's not to negate it, but it's not like you're putting in a gravity pipe, which would just be a completely different situation. So the system design is going to give you the versatility to add a lot of connections and eventually achieve full build out from a hydraulic standpoint. A lot of flexibility in that pipe size. So if you've got, let's say, a 3-inch pipe, you might only have a couple connections to that line going into that line, and it could possibly not have any problem whatsoever, including from an odor standpoint. But it's going to get you up, to 40 plus connections typically with a pipe that size. So again, we're going to want to work with you. How many total connections do you have? How many do you expect to have within a certain amount of time? And we're going to optimize it and dial it in a way that gives you the flexibility that you need, and also make sure that the system's going to work just fine with a couple connections, and it's going to work very reliably with all of the expected connections. But don't mean to take a pass on that, but we really have to look at what's going on there. One thing I can say is we will absolutely make the right recommendation for that system. And it's
and just to make up a plug for our design center on our website, definitely visit that. We have some design assistant software that's available that will, work with you or your engineer on taking a look at your topo, talking to you, and doing some analysis there. And we'll include that in some follow-up material as well. Okay, Chris, speed round, one last question.
Got it.
Do you have a recommendation on flushing station spacing? That's kind of a tongue twister there.
Typically, terminal points, intersections are where we see those. I will get the official recommendation out of our design manual, but yes, we do have that. Rachel, if we could just document that, I'd love to follow up with that person.
Yep, absolutely.
But we do recommend terminal connections. We recommend them often at intersections of pipe as well. Where
I think it's every 1,000 feet, I believe, but I'm just in marketing.
I think you're right.
Yeah. We just had someone weigh in, actually, truth be told.
There you go.
So that's good. Okay, so look, it looks like we're just about out of time here. So Chris, thank you. And to all our attendees on behalf of E1, we thank you for joining today's session and look forward to seeing you soon. Look for our follow-up email that will include a copy of this PowerPoint, as well as your certificate of attendance and some other follow-up material. So until then, be well.